The last part of this chapter is parametric differentiation. We have x in terms of t and y in terms of t. Or s and y can be in terms of s, p, q, and so on. The first parametric derivative is dy dx equals dy dt times dt dx. And you know that this is what we call the chain rule. The second parametric derivative is d squared y dx squared equals, we differentiate the first order and then divide by dx dt, or differentiate the first order times dt dx. We go to example 24 on page 20. For part A, we have x equals to t cubed. So we need to find dx dt. Dx dt equals 6t squared. And dy dt equals 8t. Dy dx equals dy dt times dt dx. So equals 8t times, for here we have dx dt. So dt dx is 1 over 6t squared. So the answer is 4 over 3t. When t equals 1, dy dx equals 4 over 3 times 1 equals 4 over 3. And for second order, d squared y dx squared equals, we need to differentiate the first order derivative one more time. And 4 over 3t can be written as 4 over 3 t power of negative 1. And then times dt dx. Okay, we got the answer for dt dx already. So we just need to find the derivative of dy dx with respect to t. So 4 over 3, the coefficient. Okay, we use the power rule, so negative 1 t power of negative 2. And times dt dx is 1 over 6t squared. So we will get negative 4 over 3t squared times 1 over 6t squared. And the answer is negative 2 over 9t power of 4. And when t equals 1, d squared y dx squared equals negative 2 over 9 times 1 power of 4 and equals negative 2 over 9. Okay, next, for part B, x and y both are trigo functions. So for x, dx dt equals negative, differentiate cos is negative sine. Negative sine, the angle is 3t. And next, we need to differentiate the angle. So the answer is 3. And we will get 3 sine 3t. For y, we can rewrite y as 2 sine 3t squared. We have power here, meaning that we need to use power rule. So dy dt equals, okay, we write 2 to the coefficient. Okay, we bring 2 the power down. Next, we copy the trigo function and reduce the power by 1. Next, we differentiate the trigo function, which is sine 3t. So we have 4 sine 3t times, differentiate sine is cos. Cos 3t is the angle, times 3. 3 is from the derivative of the angle. So we have 12 sine 3t cos 3t. Okay, to get dy dx, we need to use the chain rule. Dy dt times dt dx. So equals to, dy dt is 12 sine 3t cos 3t and times dt dx. dt dx is 1 over 3 sine 3t. And after we simplify, we will get 4 cos 3t. So when t equals, no, not for this one. Okay, so this is the final answer for dy dx. Next, for second order, the formula is differentiate the first order one more time, meaning differentiate 4 cos 3t and then multiply by dt dx, multiply by 1 over 3 sine 3t. So differentiate 4 cos x is 4. Differentiate cos is negative sine. The angle is 3t and times 3 from the angle times 1 over 3 sine 3t. And final answer will be negative 4 only.